Hello, everyone, and welcome to our webinar today on Dependency Driven Monitoring and Lineage Plus, two new big features we announced here at Bigeye recently. I'm Kyle Kirwan, co-founder and CEO at Bigeye.
And I'm Egor Gryaznov, co-founder and CTO at Bigeye.
So today we're going to tell you a little bit about what motivated us to build Dependency Driven Monitoring. We'll talk a bit about how it differs from traditional deployments of data observability. Egor is going to give us a live demo, and then we'll answer some frequently asked questions that we've got as we went through the design process that we partnered on with a number of our enterprise customers in the design of dependency-driven monitoring. So let's start with talking about our mission. So at Bigeye, we're working to empower enterprise data teams to ensure that every business user can trust their analytics. This is super important to me. I used to be a data analyst, and I want to start with a story that I used to experience sometimes, and perhaps some of you have as well. So the story begins with our data engineering person, data scientist, data analyst, getting a ping from someone in the business telling them that something looks wrong with their dashboard or with their analytics. So this usually kicks off some sort of an investigation process. We start looking at ETL jobs and we run some queries. We try to figure out what's going on. Then a few hours go by. We still haven't figured out the problem. And our VP of operations pings us again and asks how it's going. What's really happening in the background here is they have an important meeting coming up and they really want the analytics to be ready for that. We're still working on the problem, though. These things take a lot of time. So, sorry, we're still working on it. Please hang on. Then what happens a few hours later, that meeting comes up. Turns out it's with somebody in senior leadership that our VP operations doesn't have anything to present now because they don't trust the numbers. So they're just not going to do the KPI review during that sync. And they have to explain that there's something wrong with the analytics again. And, sorry, we can't do it this week. So what's happening this whole time is trust in the data and in the data team is falling. So we have a CEO who is hearing that he can't get the update on KPIs from the VP of operations. VP operations is upset because he can't actually show any of the progress that his team's been making. And of course, it's not great for us on the data team. We get pulled away from whatever we were doing so that we can go and chase down this problem in investigation. So not great for anybody, reduces trust in the data team, and less trust means less funding. It makes it harder for us to do our job and deliver value to the business. So this is definitely a failure case for the company. So let's look at what makes it so difficult, though. So let's look at this from two different perspectives. So first, let's look at it from the perspective of that VP operations. This is what data looks like to him. So it's a Power BI dashboard. It's a Tableau dashboard. When he thinks data, he's thinking about his metrics. He's thinking about how they're moving, how it's presented. What questions am I going to answer for the CEO? And this is his view of the data. But what does data look like for the person on the engineering team, on the data engineering team? So in the beginning, it might look like, well, let's dig into what's behind that Power BI report. So we start digging through some Snowflake tables. And then we realize that actually the problem might be coming from somewhere else. So we go a little further. And now we're digging into a DBT jobs and we're looking at our DAG and Airflow. And we find out there's actually also a Tableau version of this report that somebody built off of Snowflake on a different team. Then we keep going and it just gets deeper and deeper and deeper. And now we're neck deep in our enterprise data pipeline. And all this is happening in the background and causing us to not be able to have an answer for this person. And ultimately, we end up in that lack of trust scenario. So this is the reality, is that a lot of enterprise data pipelines are complicated. They have a lot of moving parts like this. And this makes it hard for us to actually understand what's going on when something is wrong with the analytics. So what if that was easy? So this is the promise of data observability, is to make that entire scenario go away. So what if we had a platform that was hooked up to all the different elements along our data pipeline? We had monitoring for things like data freshness and volume and duplicates and schema changes and anything else that could cause our pipeline to have problems. And we automatically got alerted proactively when something was wrong. So instead of finding out about the problem from the VP operations, now our data engineering manager finds out about a problem from their data observability platform. And then what they do is they use lineage and root cause analysis tools, and they easily track their way up to the source of the problem. In this case, something's wrong with SAP. And we figure out what the problem is quickly, we get it fixed. And now we have a VP operations who, maybe isn't thrilled that there was a problem with the data pipeline, but it got fixed on time. They were able to give their report, and it's not really a big deal. Things are okay. So this is the promise of data observability, is to be able to flip that reactive situation that we showed earlier to a proactive one like this, where we identify issues as soon as they start happening. We can quickly understand where they're coming from, and then we can go and implement a fix for them. So what's a company that's using data observability today and getting positive results from it? Well, a great example is Zoom. So I'm sure you're familiar with Zoom, but it's an intelligent collaboration platform that makes connecting easier, more immersive, more dynamic for businesses and individuals. This is how they describe themselves on their website. It's around 6,000 employees. And Zoom has been using data observability to really great effect. So some of the challenges that they dealt with prior to implementing data observability were a lot of ad hoc SQL checks, taking several days to be able to detect and fix issues that they were running into. And this ended up producing a lot of backfills that had to be done because it would take so long to get these issues fixed. Then you have to go and you have to backfill the pipelines. This spends a lot of compute, takes a lot of time. Some of the solutions that Zoom implemented with data observability were getting freshness and volume monitoring globally across all of their data, and then finding their key tables that really matter for their analytics dashboards and further deploying data quality monitoring on those tables. And underpinning the whole thing was using configuration as code to manage what gets monitored on which data sets through the pipelines, so that things don't have to be done ad hoc through the UI. It can be managed through configuration. And what are some of the results that they've been getting since implementing data observability? Well, they're now preventing 2 to 3 major issues each month on average. So these are issues that might have resulted in a stakeholder getting impacted that they're now able to proactively identify and solve before they end up impacting the analytics. And they're able to do that in part because the resolution time is faster. So they've cut their resolution times more than in half. They report a 70% faster average time to resolution now that they have observability in their pipelines. So these are some of the benefits that you can get once you're actually applying data observability in your environment. But let's talk a bit about how you get there. So this is the very common adoption path for a lot of teams that are rolling out data observability within an enterprise. It's very frequently driven by data engineering in the beginning. So the data engineering team will go and acquire something like Bigeye. They'll start rolling it out. Then it'll move on to analytics teams. They'll start to add data quality monitoring. Then the data governance team might get involved. We might integrate Bigeye into an existing data catalog, maybe like Elation or something like that. And then finally, at the end of this whole process, we might start monitoring for the KPIs and things that are actually feeding the dashboard. And at this point, we're now getting interaction and data observability with our embedded analytics teams that actually work in functions like FP&A or RevOps or marketing. So we started with data engineering, and then we gradually moved our way towards monitoring the end of the pipeline that's actually populating the dashboards and analytics that are built by our embedded analyst teams. So this is a very common deployment method for observability, is to kind of go from bottom to top, or if you're looking at it in a pipeline view, from left to right, from, let's say, your original transactional data sources all the way down towards your analytics. What if we could do that differently, though? This obviously takes a long time between going from your data engineering team to having observability delivering actual value to the business by monitoring the dashboard that is at the end of the pipeline. What if we went the other direction? What if we started by applying observability on the tables that directly feed our analytics products, and then worked our way backwards towards our transactional data sources? So this is the deployment concept behind dependency-driven monitoring. And this is a question that we got from our enterprise customers was, is there a way for me to get faster results to my sort of analytics teams and the users that are presenting the data to the business without having to go step by step from raw data sources through my medallion architecture and towards the dashboard? So this is sort of the principle or the theory behind dependency-driven monitoring. Why don't we start from the business and work our way backwards up the pipeline? And in theory, this should get us ROI significantly faster. And so in this world, what we can do is our VP operations can now look at a dashboard and get insights about the quality and the pipeline that's driving that dashboard directly in their browser right on the side next to, let's say, Tableau in this case. And for our data engineering manager, we can easily trace the lineage graph from that dashboard all the way back the pipeline to where the root cause might be originating from. And so how do we make this possible? Through dependency-driven monitoring and Lineage Plus. So let's break down what those two major features are that we announced that make this reverse rollout method possible. So first is dependency-driven monitoring, and this is the ability to automatically monitor the columns that actually matter in your pipeline that feed your analytics product, and to ignore all of the columns in all of the tables that don't end up in that analytics product. The value here is that you can actually enable analysts and data scientists to monitor dashboards without needing to involve data engineers. So instead of beginning with data engineers and gradually rolling out to analytics teams, we can now start with analytics teams, let them identify their dashboards that have been connected to the data observability platform, and deploy monitoring back up the pipeline by looking at all of the dependencies along the lineage from the dashboard backwards at the column level. What's really valuable about this is that we're only monitoring the fields in the data pipeline that actually matter for the dashboard. And that means that we're not wasting compute adding monitoring to any column in any table that doesn't actually impact our analytics. And it also means that we reduce alert fatigue because we're not going to generate alerts from any column that doesn't actually matter for the analyst. If we can automate this, it also means that we can get a faster deployment and a faster ROI on data observability, because we can pick our dashboard and let the tool automatically turn on monitoring for all of our upstream fields. So we're going to reduce the time it takes to deploy observability. We're going to reduce the amount of compute overhead that's required in order to monitor everything we need to ensure that the analytics are correct. And it's going to reduce the alert fatigue, because any alert that goes to the analytics team or to the data engineering team is an important one, because that alert is on a column that we know feeds into the analytics at some point. But in order to do this, in order to automatically trace all of the fields that we need to monitor to tell whether a particular dashboard is healthy or not, we're going to need really strong lineage, and we're going to need to be able to do it from the analytics tool all the way back up to the transactional data source. So this takes us to the second piece of the equation, which is Lineage Plus. So Lineage Plus is a new set of connectors that we've released, and this will grow to a full set of over 50 connectors by the end of this year. Today, we're launching with 16, and that'll give us end-to-end coverage for enterprise data pipelines, because those connectors don't only include modern data sources like Snowflake and BigQuery and Redshift, they also include enterprise technologies, think like Oracle, IBM DB2, and later in the year, we're going to be launching ETL connectors, think Power Center, Data Stage, Talend, things like that. So by having a body of connectors that can cover the entire pipeline, we can deliver real end-to-end coverage, even in an enterprise environment. And that's not possible with most data observability products that are limited only to producing lineage for modern data sources like Snowflake or Databricks, or otherwise don't support things like hybrid environments, for example, where our pipeline starts on-prem and then ends up in a cloud data warehouse. So one important piece of Lineage Plus is the ability to get true end-to-end coverage even for an enterprise data pipeline. The second important piece is that it's high-fidelity lineage all the way through. Now, what do we mean by high fidelity? We basically mean column level, but we mean automated column level all the way through without any gaps. So for example, we may be able to automate lineage on Snowflake, and we can connect to and we can represent lineage on Oracle. But if we can't automatically gather the lineage from Oracle into Snowflake, then we have gaps in our lineage, and we're going to have to go and manually fill those in. And so these limitations in a lot of off-the-shelf lineage systems means that they can technically cover lineage for your pipeline at the column level, but they don't automatically generate lineage at the column level through the whole pipeline. Lineage Plus solves this problem, and it allows us to get column level from Oracle through our ETL system into Snowflake, through multiple layers in Snowflake, all the way out into Tableau at the end. And so this is what enables dependency-driven monitoring, because without that complete coverage of the lineage pipeline, we can't apply all the monitoring that's necessary to conclusively tell whether the data in the dashboard is healthy or not. So like I mentioned, we're going to be launching with a bunch of connectors now. So starting on March 25th, we have connectors available for things like Oracle, DB2, SQL Server, SAP HANA, of course, BigQuery, Snowflake, Databricks, all the modern data sources, as well as business intelligence tools like Power BI and Tableau. And coming out later this year, there's going to be a bunch of additional connectors for enterprise technologies. That'll grow our total portfolio of connectors to 50 by the end of the year. So I'm very excited to show these connectors and Lineage Plus in action. And to do that, I'm going to turn it over to Egor to give you a demo of what it looks like to apply dependency-driven monitoring in a real pipeline.
Thanks, Kyle. I'm excited to show a demo of dependency-driven monitoring and how we can help surface the status of your dashboards and understand the quality of your data and debug the issues that arise with it proactively with Bigeye. For this demo, we're going to be exploring a company called Tunes of Our Youth. It is an online store that sells CDs, vinyls, cassettes, ships them across the United States. We're going to start with the CEO's weekly dashboard. This is a dashboard where the executive team logs in, checks the sales numbers for the week, and makes their planning decisions for next week. Now, what we're going to talk about is how the CEO can go to the dashboard, understand whether the data feeding into it is correct or not. And then from there, when it's incorrect, how a data team can quickly understand why it's incorrect and how to resolve that issue, as well as deploy monitoring after the fact. So let's start with that CEO dashboard. We're going to be in Tableau looking at the CEO dashboard. We see our sales numbers. And as I'm looking at this dashboard, I'm going to click on my Bigeye Chrome extension to check the health status of my dashboard. In this case, I can see all of the data that's feeding into this dashboard is being monitored correctly. 33 data sets and columns are feeding into this. And out of those, there's a couple of unhealthy metrics. Specifically, there seems to be an unexpected number of unique values in a column, and there seems to be problems with our value distribution. Now, the CEO might look at this and say, well, I'm not going to use this dashboard until this is resolved. I'm going to go message my data team to figure out what's going on. The data team then would go into the view of the CEO dashboard in Bigeye to understand where these problems are coming from. And here we see the CEO dashboard in Bigeye and all of the data that's feeding into it, as well as the health of that data. At this point, we see the lineage within Tableau. The CEO dashboard feeds off of 3 different sheets in Tableau. 2 of these sheets have no issues on them, and 1 sheet is at risk because the price per unit column feeding into it from Snowflake has an issue. But this isn't the actual root cause, and this is not where the data engineering team should start. This is an ETL final model table that is feeding into the dashboard. But if we look back, that's coming from a replicated source, replicated schema in Snowflake. That issue is also arising in our S3 data lake. And really, that original root cause of the problem is in our Postgres database. So let's take a look at what's going on with our price per unit column in Postgres and propagating all the way down and affecting that CEO dashboard. By clicking on this list of issues with my price per unit column, I can get on this list of what is going on with the data here. What is Bigeye detecting? We're tracking different properties of this data, and we see that a lot of them have changed. Let's focus in on this average value change. Bigeye has detected that over time, the average value in my price per unit column in my orders table tends to be between about 10 and 15.5. And it fluctuates day over day. But yesterday, that value was 7.5, which is way below what we would expect. And so this is causing this metric to alert, and therefore is impacting our CEO dashboard. Now, we traced it all the way back to our Postgres table using the lineage. But once we are within Bigeye, we can also understand what data is causing this problem. If I click on my debug tab, I can see how Bigeye is computing these metrics and these values, but I can also get a useful debug query to understand which rows are causing this metric to alert. If I click this preview button, I can see that we have some low-priced items that we sold, and then we actually sold a few items for 13 and 20 cents. This seems like it could either be a typo in a CRM, or maybe we truly did have a sale, but we can surface this issue proactively early on in the pipeline, and then quickly make the changes that we need, push the good data through the whole pipeline, and make the CEO's dashboard completely healthy. Now, some of you might be saying, well, this is great, the monitoring is already there, but it takes a long time for me to get that monitoring up and running. I have to write all these SQL queries. And that's not the case with Bigeye. Because Bigeye understands what the lineage graph looks like feeding into the CEO dashboard, we can use that same information to deploy the monitoring upstream. That is the whole point of dependency-driven monitoring. So let's take a look at an empty workspace in Bigeye. Exactly the same pipeline, exactly the same CEO dashboard, no monitoring deployed. If I click this Deploy Metrics to Dashboard button, I can get into this wizard where I can select what kind of monitoring I want. There's some customization I can do here, but what I'm going to go with is Bigeye's recommendations. We call these auto metrics. Auto metrics deploy common checks that you would want to do regardless of what the data looks like. Your distribution checks, freshness, volume, nulls, duplicates, so on and so forth. With 3 button clicks, select my auto metrics, select all of the metrics I want, and hit next. I get to my deploy screen where I can see that I'm about to deploy monitoring on 7 tables and 13 columns upstream of the CEO dashboard. In addition to that, I can assign all of these metrics to myself because I need to know whenever something goes wrong, and the alerts will get routed appropriately. By hitting deploy, like I said earlier, in 4 button clicks, Bigeye can use dependency-driven monitoring to help you deploy 53 different checks across the whole pipeline without requiring you to go in and write any SQL or any code or change any pipeline logic at all. So hopefully this gives you a better understanding of how dependency-driven monitoring works, both from a deployment perspective, as well as what happens when problems get detected and how do we surface that information to your stakeholders, as well as to the people solving the problem. With that, as we've been rolling out dependency-driven monitoring and talking to our customers, we have gotten a couple of common questions about the lineage functionality, as well as the monitoring, and some questions that are common we'd love to answer right now so you can get a better sense of how this technology works. So with that, let's jump into our FAQ section where we can discuss our dependency. So first question is how does Bigeye Lineage, is Bigeye Lineage Plus able to trace this lineage from cloud to on-prem systems? So Bigeye is a hybrid SaaS solution. All of the anomaly detection, configuration, UI, machine learning, that happens in Bigeye's cloud as a SaaS product. However, connectivity to on-prem systems is often complicated, and nobody wants to expose any networking, any ports to the outside world. Bigeye has an agent model that deploys these forward deployed agents into your on-prem environment in order to collect the metadata that we need, run the queries that we need in order to trace these metrics, and then do all of the heavy lifting in the cloud side. This allows us to separate out the data plane and the control plane, making sure that all of the raw data, all of the connectivity stays inside of your environment. The ability then once that data is aggregated centrally, we can surface the lineage information both from your cloud systems, such as Tableau, or it's Tableau, Snowflake, Power BI, or if you're using on-prem Tableau with Cloud Snowflake, we can start mix and matching these connections and gathering all the information centrally. And as Kyle mentioned, later on this year, we'll be adding a lot of ETL connectors for these on-prem deployments to allow us to automate a lot more of the within the on-prem system connectivity from your transactional system through your ETL tools into your data lake or data warehouse at the end. The next question is, can Bigeye monitor dependencies for things other than BI dashboards, such as ML models or data products more generally? The answer is yes. The lineage graph that we've shown today is all automated. Our goal is to automate as much of that gathering, data gathering and lineage inference as possible. However, Bigeye is a fully extensible system. Everything you can do in the UI, you can do via an API. And so if you have sources that Bigeye can't connect to, you can import the lineage into the graph, and it will be there alongside all of your other assets. And you can use the same workflows of dependency-driven monitoring to deploy that monitoring upstream of those data products. So, for example, if you have a machine learning model that's feeding off of a training data set in Snowflake, you can add that machine learning model node into the graph. You can click on it the same way I clicked on the CEO dashboard and click deploy monitoring to it, and it would deploy the monitoring upstream of that machine learning model and then aggregate that quality information and give you that proactive alerting about any issues with the data feeding into the training set of your model. So for the next question, is dependency-driven monitoring a separate product or part of the Bigeye data observability platform? This is all, dependency-driven monitoring is the approach that Bigeye encourages through its platform. We believe that this will allow you to quickly realize value through it in a data observability platform by focusing on the data where the data is being used and is most important, and monitoring only the things that are important to your business. Dependency-driven monitoring and Lineage Plus are part of the platform, and they are included when you purchase Bigeye. Number 4, how is dependency-driven monitoring different than competitive alternatives? So lineage is a common term. You can't look at a data tool without hearing the word lineage. That said, lineage is often used as information in these tools in order to understand what the systems look like. Dependency-driven monitoring takes another step forward by using that lineage information in order to drive the kinds of workflows that you need in order to scale out your data observability program. By being able to deploy 54 different metrics in 3 clicks, by being able to understand the state of the data feeding into the dashboard, feeding into that ML model, allows you to scale out and maintain a high level of visibility through the whole pipeline, rather than using it as information and then still having to rely on institutional knowledge and custom reports in order to get that same information. In addition to this, because dependency-driven monitoring is powered by Lineage Plus and all of those connectors that we are launching, we will support a much broader variety of systems, both modern as well as more legacy systems. And we can combine the information through all of them, whereas more other tools tend to support only cloud-based products because those are often easier. But we at Bigeye here understand that your data environment is much more complex, and therefore you do need an observability platform that can scale to the whole data environment.
In terms of what that means during the deployment, though, number 1 is the speed. So as Egor mentioned, you're going to leverage the lineage graph to apply monitoring automatically to the fields that roll into your analytics. What that means is that, as I showed earlier, in a traditional bottom to top or left to right style deployment, you've got to go layer by layer from your transactional data source towards your analytics. With dependency-driven monitoring, you can apply monitoring in, as Egor showed in the demo, a few clicks, and we can get all the metrics that we need deployed all the way up the pipeline from the analytics product. So the time to deployment is significantly faster. That's benefit number one. Benefit number two is we're only spending compute overhead to monitor the columns that matter. So we would get this question a lot from especially enterprises where their compute bill can be pretty sizable. How much is data observability going to increase my compute costs? And with dependency-driven monitoring, we're able to minimize that overhead and compute costs because we're only going to apply monitoring to fields that actually need it, as opposed to solutions where monitoring is all or nothing for tables or schemas at a time. This is a much more selective approach, which reduces the additional compute costs. And then last is alert fatigue. So when we're getting alerts from an observability system, we want to know that those are actionable alerts that matter. With dependency-driven monitoring, we're only getting alerts on columns that ultimately end up in our dashboard. And that means that those are high-value alerts as opposed to getting alert noise on columns that may or may not have anything to do with the analytics themselves. So those are some key benefits in dependency-driven monitoring that are a result of the different technical architecture.
And finally, number 5, what types of checks are included in dependency-driven monitoring, and is it easy to create new or customized checks? So everything that's included in the Bigeye platform out of the box, and we have over 70 metrics that are included out of the box, can be deployed with dependency-driven monitoring. In addition to that, Bigeye as a platform allows you to define your own custom logic and build your own custom checks and scale out the deployment of those along the lineage graph through dependency-driven monitoring in the same way that you would scale out any of the out-of-the-box metrics. So everything that comes with Bigeye, as well as anything you can think of to monitor, can be deployed with dependency-driven monitoring.
All right, thanks for going over those frequently asked questions. And for the demo, Egor, to close things out, I hope you enjoyed the webinar that you learned about data dependency-driven monitoring and about Lineage Plus. We're both very excited to finally unveil these features after several months of building together with some of our enterprise design partners. If you'd like an in-depth demo and to get some direct Q&A time, please schedule a demo with us. You can use this QR code. We'd be happy to schedule some time, take you through the demo, answer any specific questions, talk about the connectors that we have coming out and how they're going to work in your pipelines. So we look forward to connecting with you there. Thanks for watching. I'm Kyle.
And I'm Egor. Thanks for your time.
Have a good one. Bye.